Hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So in today's video we are going to learn how we can create and composite image out of the image collection and what's the difference between the different types of reducers in order to reduce an image collection into a composite, like we are using the mean composite, median composite, and also the mosaic function in order to have a single image out of a collection of images. So let's start by importing our Sentinel-2 dataset. So search for Sentinel. So I'm using the harmonized Sentinel-2 multispectral instrument. So we just import this and rename it as S2. And I also need a region of interest. So I'm searching for an area in the Bangalore in India. So if you can just search here, I'll get the Bangalore. So you can use the geometry tools in order to add a marker, a line, a polygon, or a proper rectangle. So I'm using just a point tool in order to create a geometry, and I'm renaming as region of interest, ROI for short. So now let us filter our image collection. So this is our previous tutorial, the tutorial number 12, filtering an image collection. So I'm applying the same filters in order to have the filtering functions. So let's create a variable called image, or you can say filtered image collection is the variable name. Okay, so I'm selecting the S2 Sentinel data. I'm first time applying the filter bounds function in order to filter for the boundary. So this filter will basically reduce or filter our satellite image collection to into the boundary of our region of interest. So in our case, it's the Bangalore is our region of interest. So I'm using the function s2 dot filter bounds to region of interest. So in order to know how clearly it will work, so you can just print uh, this filtered image collection variable in order to know how the image collection varies and how the filtering works. So if you can just click on the run, the image collection is computing. So it has 260 elements. It means for our boundary it has 260 images out of the Sentinel-2 data. So next I'm applying one more filter, which is called as filter date. So now I want to filter my image collection to the various data sets. So I'm filtering it out to the latest for the 2024 January till 2024 December 16 or December 10, anything you can take. So it will give you the latest image. So now let's click again on the run in order to know how much images have been filtered out. You can see here from the 600 elements it has been reduced to 68 elements now. It means for the 2024 year we have the 68 images. So if you can just open the features here, you will see the date 2024 January 3. So these are all the latest collections. So the latest available is the 2024 December 8 is the last image which we have in our collection. So if you can give the today's date, that is 17, uh, the image collection number might increase. Yeah, here now you will see you will have the 69 elements, and the latest image is captured on the 24 the no 30th December of 2024. So that is the latest image which is available. So now I have the filter date function, I have the filter boundary function. So let's again filter the metadata. So the filter metadata function is used in order to reduce the cloud cover over an pixel. So here I'm copying this property of an image called cloudy pixel percentage. So this will depict how much of the cloud is there in each of the image. So if you can just open in here and you see the properties, this pixels, this image's particular cloudy pixel percentage is 76%. So if I carry on any kind of analysis on this image, it will be of less accuracy. So I'm pasting our property name cloudy pixel percentage, and I'm giving the arguments less than say 1%. So let's run it again. So my 68 image collection is now reduced to only 12 elements. It means the image collections or the image which have the cloudy pixel percentage of less than 1%, and it is captured in the date of 2024 year between January to December, and it is present in my region of interest, that is Bangalore. For these filters we have 12 image collections, 12 image. So you can just open the filters. Here you will see, let's check it on the first image. So here you will see this is the date 2024 118, that is January 18 2024. And if you can just expand the bands list, it has the 18 bands. And the properties here you can see which I have clipped it out, which I have filtered. It is the cloudy pixel percentage is only 0.06. So I think this much of filtering is enough to carry out any analysis. So you can still reduce the cloudy pixel percentage if you want. Let's say if I reduce to 0.1%, let's see how many image collections are available. You see I have 9 elements which have cloudy pixel percentage of less than 0.1%. So it's a better data set. Let's continue. So here you can see it's an image collection. If I print it in the console, here you will see it's an image collection. So in order to carry out any analysis, like for example, in order to calculate an indices like NDVI, NDWI, or SAVI, the soil adjusted vegetation index, we need a single image. So how to get the best out of it? So we are using the reducer functions called mean, median, or the fast function, etc. So in order to visualize better, let's use the function called dot first. So here you will see this function is used in order to visualize my first feature. So here you will see this is my first feature which is captured on 2024 1 18, that is January 18. So now if I print my image collection, it will select the first band. Yeah, here you'll see my first image has been selected for now. So let's add it to the map. In order to know the differences between the various kind of composites which are available in the Google Earth Engine, so I am adding map.add layer filtered image collection to the map, and I'm defining the visualization parameters such as the minimum should be let's say 0, and the maximum should be 3000. So the reflectance for any object on the land cover will vary from 0 to 0.3 for the sentinel dataset, but here we are using the 3000 as the maximum value. This is because if I go to our bands list, so here you will see our band 1, band 2, band 3, everything is there. So here you will get a scale which is 0.001 is the scale. It means in order to carry out any analysis, I need to multiply the bands first with this 0.001 scale, then I should carry out the analysis. So that's the meaning of scale. Why Sentinel or the ESA does this? Because uh, storing the dataset in terms of integer will consume the less storage as compared to storing them in a float function. So they will usually give it in an integer type, then they will let us ourselves to multiply the scale value and carry out the analysis. So since I have not applied the scale yet, I am using the original values from minimum to maximum as 3000 to be the reflectance, and I am renaming it as let's say it's a first image. Okay, and I should also give the bands list, while visualizing more than one band. So I'm currently using the true color composite, red green blue, for red green blue only. Okay, so now let's give a run. Now my image should load. Yeah, I have one single image, which is the first image which is intersecting with my region of interest. So we'll see the differences now. So you can just copy paste this, copy the first code, and paste it in the lower layers. So here you will rename this as mean composite. Okay, so also replace this first function with a reducer called median or mean. Sorry, we are using mean. Median will use next, and I will also add this to the map. So you can just copy paste. That's the beauty of Google Earth Engine. So if you paste it in here, it should be a mean composite, and again the value ranges from 0 to 3000, and I will rename this as mean composite image. Okay, let's give it a run. Now I have two layers in my layers panel, which is adding to the map. So if you can just see the difference between the first image and the main composite image, you can slightly see the difference, because the mean composite image has taken the reflectances out of all these 9 elements, and it has calculated the mean value, and it has given the output. So out of the first image and the mean image, which one do you think is better? So for me, I think it's the mean composite which is better than having a single image for your analysis. So we have one more reducer which is called as median composite. So let's add that also to the map. You can just copy paste it. So instead of mean, you replace it by median, and you should also change the reducer type to median in the line number 26, and replace this with the median, and instead of mean you replace by again median. So let's give it a run again. We have 3 layers now loading in my layers panel. Yeah, now you have my single image which is not a composite, and I have my mean composite, I have my median composite. So out of the three, which one is better? So let's use the inspector column. You can click on any images. So here it's a graph, it's a much more complicated. We'll just choose the visualization like this. So here you can see out of the mean and median there is not much of a difference, but if you can compare the single first image with the median and mean, there is a evident difference which can be seen. So the reflectances are optimized at the median as well as the mean reduced image composite, and it's better to use the median as well as the mean composite image instead of using a single image. So I think you have understood how we can go for uh, creating a single image out of the filtered collection. So once again I will wrap up. So we'll import our sentinel-2 image, and we will apply the filter date function in order to filter it out to date of our interest, and we will also filter out to our boundary, which is our region of interest. We can have any point, we can have any line, polygon, or a proper rectangle. You can draw anything, and you can define your region of interest. If you have any kind of admin boundary, then you can also import that. And next we have filtered our cloudy pixel percentage with the help of the function filter metadata to less than 0.1%. We had the 9 images available for our region of interest, and we next we use the various kind of reducers in order to reduce and filter image collection into a single image. So we have added all those 3 methods into our map using the first method and the mean method as well as the median method. So out of which we have derived that the mean and median are more or less one and the same, and the first image, which is not a composite, it is just a single image, have the low reflectances as compared to the mean and median composite. So I hope you have understood uh, this tutorial, guys. So if you have any kind of queries, doubts, you can post it in the comment section always, and also I will also provide the link for this code snippet in the description box. uh, Thank you for watching.